We will discuss the structure of the functional group. So here in the diagram I have shown on the board, you can see that this is the methyl alcohol or methanol structure which is depicted here. The carbon atom, right, undergoes sp3 hybridization and it has got 4 sp3 hybrid orbitals with which it is holding 1s and another 1s to form the CH3 part alkyl group, and the one left sp3 hybrid orbital, it overlaps with the sp3 hybrid orbitals of oxygen atom and form a bond here. Sigma bond is formed, right? And oxygen also undergoes the sp3 hybridization, and in one it is holding the it will be holding the two sp3 hybrid orbital, it is holding the two lone pairs, and with one sp3 hybrid orbital it is overlapping with the 1s of the hydrogen, right? Now since it is undergoing sp3 hybridization, so the expected bond angle, student, is 109 degree 28 minutes, or it is 109.5 degree. But due to the presence of two lone pair, right, you can see here that here we have two lone pair on oxygen atom, there will be repulsion and the bond angle is going to reduce from 109 degree or 109.5 degree to 105.5 degree. Hope so it is clear that why the tetrahedral angle reduced to 105.5 degree in alcohol. So why it is so, student? Due to the presence of two lone pair on oxygen atom, right? Now if we just compare the bond angle in alcohol with the bond angle in phenol, here, student, the bond angle between the carbon O and H, COH, tetrahedral bond angle, it has not been observed here. It has been reduced to 109 degree, right? Then also you can see that, compare the bond angle in the aliphatic alcohol and that in the phenol. You can see that phenol, the bond angle is only 109 degree, and whereas in alcohol it is 105.5 degree. So why this? Here the angle is not being reduced to that extent because of the, we can say, the presence of the phenyl group. There will be the, we can say, the lone pair on the oxygen atom, they have been pulled up by the benzene ring, right? So as a result, the bond angle is not that much reduced as it is reduced in the alcohol. Now when the lone pair will be pulled by the benzene ring, student, what will happen? There will be the partial double bond character which will also arise between C-OH bond, right? So partial double bond character arises in phenol due to resonance, right? Now one more thing is there, student. If we, okay, so what will happen if the partial double bond character has arisen? Definitely the bond length between C dash and the aromatic ring and between O, that is, we can say C dash O, this bond length will be less than that in the C dash O of the alcohol. So here we have to just check three things actually. First is the bond angle, second is the bond length, and third is the dipole moment, right? So we will discuss under the structure of functional group, three things we are going to discuss. First is the bond angle, second is the bond length, and third is the dipole moment, right? Now we have discussed the bond angle, that in bond angle in phenol is slightly is greater or is just near to the tetrahedral bond angle, right? And in alcohol the bond angle is being reduced to greater extent. It's 105.5 degree, and that too, why it is so? Due to the presence of the lone pair, which is more concentrated on the benzene, on the oxygen atom, and hence there will be more lone pair repulsion. But such repulsion is getting reduced when we talk about the phenol. There, hence the bond angle repulsion is minimized. As a result, the bond angle is not being reduced too much from the tetrahedral angle. Second thing comes the bond length. Now the bond length in C-O in aliphatic alcohol will be more with respect to that of the phenol. So in phenol, aromatic alcohol, that is in phenol, the bond length is rather less than that in the aliphatic alcohol. And that is why, because of the conjugation, or we can say to the resonance, the partial double bond character arises in C-O. So definitely the bond length of double bond is less than that of the C-O, that is single bond. Now third thing which I am talking here is the dipole movement. Now student, dipole movement is related with the polarity of the bond, right? So we will discuss it. So as I said, that we will discuss under this. First is the bond angle, second is the bond length, and student, third is the dipole movement. So students, the dipole movement of methanol, right, is greater than phenol, right? So dipole movement, it is in this way C-OH, this one. This is in phenol. So here will be partial positive character carbon with respect to C-O bond. Here will be partial negative, and here again it is partial positive. So the dipole movement, of methanol molecule will be more, right? It will be high dipole moment. But if we see phenol, so student, in phenol, I am just pointing out this C, it is O-H. Definitely, with respect to this O-H bond, the oxygen will get the partial negative. Now, this carbon also, which is attached to it, right, from this side, the polarity of the bond is going to get reduced due to the resonance effect, or we can say due to the the electron withdrawing effect of the benzene ring. So the polarity of C-OH gets reduced. The polarity of C-OH is reduced due to electron withdrawing EW, that is electron withdrawing effect of benzene, right? And here the polarity is more, right? So the dipole moment, if polarity will be more, student, definitely dipole moment, it is related with the magnitude of the polarity of a bond. So if the polarity of the bond in aliphatic alcohol, right, if it is more, then what will happen? The dipole moment will be more. And whereas in phenol, the polarity of the bond C-O gets reduced due to the resonance effect, right, due to the electron withdrawing effect of the benzene ring. Hence, the polarity is reduced. As a result, the dipole moment will also get reduced, right? So, just these are the three important, and mainly from here also questions can be put up to you related with the comparison between the alcohol and the phenol regarding the bond angle, bond length and the dipole moment. So, just get it prepared.